So in this video, I'm going to talk about how you can control the density of two objects or more when scattering objects onto a surface. So currently I have this setup of an ArcViz scene, as you can see here, and what I want to do is I want to scatter grass onto this surface. So you could do this with the particle system, or you could use geometry nodes. So I have a setup here with geometry nodes where I'm using the collection info node to scatter this grass onto the surface. Now, I have three types of grass in this collection. Let me find the collection. There we go. So I have the bushy grass, which is what you can see. I'll just show you the model. So I have these three models. So in order to achieve a realistic looking grass, like grass isn't all just the same. So you've got like a thick grass, I've got a lawn grass, and I've got this kind of wild grass that I'd like to use on the patch that I'm trying to populate. So obviously this will get populated onto all the surfaces. So currently, I mean, if I take this separate components node out, if I just take it out, what's happening here is it's basically just populating everything in there. If you look in here, right, there's going to be, I mean, it's difficult to see probably from my screen capture, but you're going to have all three models on there, and there's no way to actually control what's what, right? So what you could do, one alternative would be to pipe this through a separate components node, right? In which case, instances, sorry. In which case I could get one, the second, or the third type of model in there. So if we look in here, I've just got the first one in the list, which is the bushy grass. But that's not what I want, and I couldn't figure out how to maybe use this separate components node to populate two different instances, two different types of instances of the grass onto the surface, right? So just using a collection info node just sticks everything in there. There's no way to control the density. If you separate components, it's probably going to go for the first one in the layer. The way the collection info node works is it works on an alphabetical order in the layer. So I've got bushy grass with the B, L, and the W. So this would get populated first, this would get populated second, and this would get populated last. So I was looking for a solution, and I came upon this one. So about 2 years ago, someone asked the question, how would you control the density of individual objects from a collection info node? So this person's user called, I'm trying to find his name, but I'll link the file, and you can see this isn't my solution, this is this person's solution. So what he's done is he's essentially, in programming terms, he's created a makeshift array, and then from the array he sets up a probability of which of the three items in the collection info node would get picked. So basically he's got a collection info node here. I mean, I don't know if it's very clear on the screen. That goes into domain size node that on instances that tells you how many items there are in the layer or the array. Arrays always start from 0, so what he's doing is he's adding 1 to this. This connects to a mesh line node. So a mesh line node basically creates a line with points. So what he's doing is this is getting piped into an index, something called an index density node. Now this is a group node that he's created. And what this does is it increases the size of the edge. So you add points. So in this index density node, if you just bear with me for a second, I'll show you what he's done. So he's got a breakdown here, right? So index is a fixed quality, is a fixed attribute that can't be changed. So what he's doing is, this is a group node. So the index is going into an equal to node, so which is just telling the set position node where that item is. He's then adding 1 to it, and then he's adding 1 to the outgoing node. So each one that follows the previous one in the progression gets added to once. At least that's my understanding of it. And then he's using a random, so just going down here, he's using a random value node to determine which one's getting selected, and he's named them index density nodes. And then this, you know, gets piped into the instance on points. And I mean, you can look at this page, and it's, I mean, he's gone into more detail with, you know, deforming the objects and things like that. So all I used was just this top part, and I can show you my implementation of this. So here's my implementation of this, and if you look at this grass, if you look closely, you're going to see a mixture of the little wild grasses mixed in with the lawn grass. So if we go to the geometry nodes window, I'll show you what I did, right? Let me just increase this out in size. So I've used his solution here. So I start off with a distribute to points node, instance on points, join geometry, and group output. So here is where the magic happens. So I've got my collection info node, and in my collection info node, I've got 3 items here. I've got bushy grass, I've got wild grass, and I've got the low poly. I mean, this I'm not using. So I'll just take that out. So I'm using these 2 because I wanted to mix these 2. So I'm going in with a domain size node, which calculates the number of items in the layer. So there's 2 here, it adds 1 because arrays always start with 0, so you want to add 1. Going in with a mesh line node, and then if I open up my, this is his index density node that he's talked about. So what I'm doing is I'm going in at the position, just using an equal node, and that tells the line, the mesh line node, where to place the point. You add 1 to it, and then you add 1 to the index. So this is saying let's go to the next item in the array, right? So you're adding a point, and you're telling the collection info where to go next. So you're adding 1 here, and you're adding a point here. And if we go back to the multi-object scatter, I mean, I have 3 items here and I'm only using 2, but I've left 3 nodes in here. So what happens then is you pipe these 3. These 3 will determine the items in the collection info node. This is the sample nearest node, which is going to pick up, no, first it goes into random value. So this determines the density. This is picking up what density you want. So you basically, when you set up this node, you create some attributes in here, right? So I'll just show you how that was done. It's not very clear from the post. So what I've done here is I've created input attributes and output attributes, right? So the input attributes is the line, which is a mesh line node. So it's just geometry and it's just a line. The sum is the point attribute, you know, when you're adding points to the mesh line. So it's a sum and it's a float. It can go from 1 to 1,000. The auto index is what's telling the array what needs to be populated next. This is an integer. It can go from 1 to this. Blender just puts in by itself. You just leave that at 1. And then you have the density node, which controls how thick the scatter will be. So I've set mine to 1,000,000. The default's 0.5 and the minimum is 0. So those are the input attributes. So the output attributes for this, what's going to go out, the output attribute is what's going to go to the next node. So it's the geometry, which talks about the mesh line, the sum, which is the point, next point to add, and the index, which is the next item in the array that needs to be included. So I know this is a little bit complicated, but as you can see from the scene, it actually works, right? I've got my mix of the two grasses. The files that this person has used are here on the Stack Exchange page. If you want to investigate this by yourself, I'm not a programmer or an engineer, and I've just tried to understand this as best as I could, and I've recreated it for myself. If you leave me a like and a comment, I can let you have my sample file, which I've used expressly for the purpose of this vegetation. Obviously I won't include the models. I'll just give you the setup I've used, and then you can use the setup. But please leave me a like or a follow on my YouTube, as this helps me to continue making these problem solving videos. Thank you very much for your time.